Hello everyone, this is a problem from Resnick and Walker, problem number 56 from chapter 23. In this problem is said that the electric field in a particular space, that electric field is given E equal x plus 2 into I hat towards that positive x direction, so that's why I draw in that direction. This is my reference axis. Now where x is in meter. Now this is a cylinder which has the radius r, and this radius r is basically just given that r is 20 centimeter, and that is coaxial with x-axis. This is the x-axis. One end of the cylinder at x equal to 0 and other end at x equal to 2 meter. Now they ask you what is the magnitude of the electric flux through the other end of the cylinder. So that end, what will be the electric flux, and what is the net charge enclosed with that cylinder. Fine. To solve this one, we are going to identify there are three surfaces. Say this is actually surface 1, I label by this is S1. This is the curved surface, say that S2, and this is that another surface which is S3. So they are asking me to calculate in question number 1 what is the flux through the surface 3. Now to solve that one, basically what we are going to do, we have to draw that we are going to use that formula for Gauss's law, this one, which would be phi would be basically enclose E dot dA, right? That's with that formula. So that part we are going to use to solve that one, question number A. Fine. Now we have to draw that electric field into that direction. Since electric field towards that direction, I can draw this would be that direction of that electric field for that surface in that direction, and the area vector would be also toward that direction, right? It means that these two vectors are parallel each other. What about this case? In that region, so electric field is toward that direction, but that area vector would be perpendicular to that surface in every point out on this curved surface. So that's why every time in the surface 2, the electric field and area vector would be perpendicular to each other. What about that surface 1? In that case, that electric field direction is toward that direction, right, which is C, but for area vector for this surface would be towards that direction. So this is would be that area vector. We can write, so this is for area vector from surface 1, this is would be that area vector from surface 2, and this is would be say that area vector from surface 3. This is actually that we draw that vector. Now in the first question they asked me find out that electric flux through the other end of the cylinder at x equal to 2 meters. So that means surface 3. So I'll write that flux through the surface 3, that's why I write down phi 3. It should be close E dot dA 3, right? But these two vectors are parallel to each other, so that's why angle will be the 0 and cos 0 basically 1. So we'll find out dA 3. So if we integrate, what we will find out basically, provided, remember this phi 3, I'm sorry I make a mistake, this phi 3 would be because electric field is a function of x, so that's why we have to write down this would be phi 3, I'm sorry I mistake a line, so x equal to the 2, right? We have to write down this thing over here. Basically if you change the value of x, then your surface is going to be the difference. Say for example, if you say x equal to 0, then it's going to be the surface 1, right? Then we can write So E is basically x plus 2, and if you integrate this one, D, you'll find out A at x equal to basically 2. So I'm going to plug in that value of x. So if I plug in, what I'll find this is going to be that 2 plus 2 plus 2 into A3, that would be pi r square, area of the circular region, because that has a radius which is basically that r, right? And r is given. Now we can find out that flux for this surface. So in that case it's going to be that 4 pi r square, then 4 into 3.14 into that r is 20 centimeter, so that's mean 0.2 meter, right? Or you can write 0.2 meter square. If you solve, then you will find out that flux for this through the surface 3, that's going to be 0.50 Newton meter square per coulomb. So that is will be the answer of that question number 1. So this is that answer of question number 1. Fine. Now for question number B, what is the net charge enclosed within the cylinder? So we have to find out that net charge through that cylinder. Okay, fine, we can use that one. For that one we have to use the, again, that we have to find out the net flux through this cylinder, right? So net flux would be, again we can write, say that E dot dA must be equal to Q enclosed divided by epsilon naught, right? So we'll use that formula to find out that Q net. So that's mean we can write from there Q enclosed would be basically phi net into epsilon naught. So that would be my formula to find out that Q net. Now what is phi net? So phi net would be total phi net, we can find out. So it would be phi provided by that surface 1, you can write down S1, plus provided by the electric flux by surface 2, plus provided by that electric flux by surface 3, right? Then we can write what would be that case, phi net, we can write in a form. So it would be E dot dA1 is a close, plus this is for surface 1, and for enclose E dot dA2, this is for surface 2, plus enclose E dot dA3 enclosed, right? Now for the surface 2, look at this, electric field and the area vector are perpendicular to each other, right? So that's why the contribution by this one is going to be the 0, and we can find out in that case that electric flux for surface 1, it could be, and remember this surface 1 would be the condition, because electric field is a variable over here, provided at x equal to 0, plus electric flux for surface 3, which is S3, provided at x equal to 2, right? Now look at this over here, we'll find out this phi net. We can write this case for the surface one, electric field and the area vector are opposite directions, so that's mean angle between these two vector is 180 degree, right? So that's why we write this will be minus E into surface dA, this is for surface 1, plus this would be, for this case angle is basically 0 degree. I should write that line. So it's a, so that's a cos 0 is basically 1. So at x equal to 2, right? For surface 3, that area vector and the electric vector are parallel to each other, but for the surface 1 they are anti-parallel. For surface 2 they are perpendicular to each other. Fine. Then we can write this phi net would be, this is actually E would be 0 plus 2, right? Because electric field as a function of x plus 2 I hate, right? So I put the plug in the value of x over here. So if you integrate this one, you will find out, integrate d1, you will find out a1 plus this is would be 2 plus 2. I plug in the value of x into a3, right? Now this is going to be phi net, it basically minus 2a plus this is going to be that 4ay. We find out that area of surface 1 must be equal to area of surface 2, which would be basically pi r square, right? The radius is same for both surface 1 and the surface 2. Fine. Then we'll find out this would be phi net would be 2a, which is going to be 2 into pi r square. That's with that total flux we can write, so it will be the Newton meter square per coulomb. Now I'm going to find out that enclosed charge. So enclosed charge would be, now q net enclosed charge would be phi net into epsilon naught, which is 2 into 3.14 into radius is 0.2 square into epsilon naught is 8.85 into 10 to the minus 12. So if you solve, then you will find out that q net charge enclosed by this cylinder, it be 2.22 into 10 to the power minus 12 coulomb. So that should be basically the net charge enclosed by that cylinder. So this should be the answer of that question number B. Okay, thank you very much.